Have you ever really stopped to think about what it means when we say a machine learns? I mean, not just following a pre-written set of instructions, but actually figuring things out for itself. Well, today, we're going to do just that. We're pulling back the curtain and building a learning machine right here from the ground up.
All right, so let's break this down. For the longest time, programming worked the old-school way you see on the left. You, the human, had to figure out the exact formula, like the one for converting Celsius to Fahrenheit, and you just code that rule into the computer. Easy enough. But machine learning, whoa, it completely flips that on its head. Instead of giving the computer the rule, we just give it a ton of examples. We show it pairs of temperatures and basically say, here's the data, you go figure out the rule.
And that, right there, is the million-dollar question we're tackling. How in the world can a machine discover a rule that we never actually gave it? I know, it kind of feels like magic, doesn't it? But stick with me. I promise. It's not magic. It's just some really, really clever logic.
So let's get our hands dirty and see this in action. We're going to start with the absolute classic hello world of machine learning, teaching a machine to convert temperatures. But there's a big catch.
Here's the challenge we're setting up. The model will never see the famous conversion formula. Nope. All it gets is data, just pairs of numbers. You know, we tell it, hey, 0 degrees Celsius is 32 Fahrenheit, and 10 Celsius is 50 Fahrenheit, and so on. Its only job is to stare at those numbers and find the hidden connection. So where does it even begin? Well, it does what you or I might do if we had no clue. It takes a totally random guess. Seriously, it's like it just closes its eyes and draws a line on the graph. And yeah, that first guess is, well, it's terrible. It's basically the machine shrugging and saying, how about this?
Okay, but this is where the genius part kicks in. It doesn't just throw that bad guess away and take another random shot. No way. It actually looks at its own mistake. It measures exactly how wrong it was. You see the distance between its line and the real data points? That gap, that error, that becomes the most valuable clue it has. And using that clue, that error score, it makes a tiny, smart adjustment. It just nudges the line a little bit. It asks itself, okay, if I tilt the line this way, does my error get smaller? Yes? Cool. It's not one giant leap to the right answer. It's just a small, calculated step in the right direction. And that simple little loop, guess, measure the error, adjust, that right there is the heart of machine learning. It just does that over and over and over again. We're talking thousands of times. And with each tiny cycle, it gets a little bit better, nudging that line closer and closer until it finds the absolute best possible fit for the data. So, after all that work, what do we get? Well, now we can test it. We give it a Celsius value it has never seen before, like 100 degrees. And check out its prediction. 211.99. The real answer is 212. That is incredibly close. It did it. It actually learned the rule without us ever telling it what the rule was.
Okay, so fitting a simple line is the absolute foundation. But now let's level up. Let's take that same core idea and build something way more powerful. We're moving from a single line to a tiny artificial brain, a basic neural network.
So here's our simple blueprint. Think of it like a little assembly line. Information comes in on one side through a couple of input neurons. Then it gets processed and crunched in the middle by a hidden layer of 3 more neurons. And finally, the answer, the prediction, pops out the other side from a single output neuron. It might look simple, but trust me, this is the basic design behind those massive AIs you hear about.
And the key here is that we're doing this from scratch. As this quote points out, when you avoid the fancy, high-level tools, you're forced to actually grapple with what's going on under the hood. You get to see the gears turn, you know? And that's the best way to really get it.
All right, let's zoom in a bit closer. How does this little brain of ours actually learn anything? Well, it all boils down to a constant 2-step dance that's always happening inside.
First up is the forward pass. This is the easy part. Data flows forward through the network, from input through the middle to the output, and it makes a prediction. That's its guess. Then comes step 2, the backward pass. This is where the real learning happens. The error from that guess is sent backwards through the entire network. It's like a wave of feedback telling every single connection how to adjust itself to do a little bit better next time.
Now, inside every single one of those neurons is a critical component called an activation function. The best way to think of it is not as a simple on-off light switch, but more like a dimmer switch. Based on the signals coming in, it decides not just if a neuron should fire, but how strongly it should fire. And that little bit of nuance is what lets the network learn patterns that are way more complex than just a straight line. So to know how to get better, the network needs a grade on its performance, right? That's the job of the loss function. You can think of it as the network's report card. It compares the network's prediction to the actual right answer, and it calculates a single score that perfectly sums up just how wrong it was.
And finally, we have the optimizer. If the loss function is a report card, the optimizer is like a smart tutor. It takes that bad grade from the report card and uses it to come up with a study plan. It's the engine that drives the learning, systematically tweaking all the connections in the network to make sure the next guess is always just a little bit better than the last one.
Okay, let's pull back. We've seen all the individual parts, all the gears and levers. Now let's look at the whole incredible machine we've just put together.
It's pretty amazing when you think about it. We started with such a simple idea, just nudging a straight line to fit some dots on a graph. And now we see how that exact same core process of guessing, measuring your error, and making a tiny adjustment is scaled up to power an entire network of interconnected neurons, all working together to find patterns.
And that leaves us with the pretty mind-bending thought to end on. If this simple, repetitive loop of guess and correct is the fundamental way that machines learn, from our simple temperature problem all the way up to understanding human language, what's the limit? What are the patterns out there in our world that a system like this can't eventually find?